This is a single replacement reaction, and I know this because I have a single element and I also have a compound. So the first thing we're going to need to do whenever I do a type of reaction like this is I'm going to figure out what the charge is. So copper happens to be a little tricky though because it's a transition metal, but I do know I have two coppers. And I also know that it's bonded with only one oxygen. So if I know the charge of oxygen is -2, that tells me that the overall charge of my copper ions has to be a +2. So in order to do that, since I have two of them, each one has to be +1. So in this case, I know that copper has a +1 charge. So I'm going to just put that up there. Oxygen is -2. And then even though sulfur isn't combined with anything, I'm still going to write the charge just so that I remember that I have to make it neutral when I make the formulas on the other side. So when I'm looking at this, trying to figure out what's going to switch, I see a negative and a negative. So those two things are going to switch spots. So when that happens, I will have Cu, which is +1, and an S, so I'm going to need two coppers for every one sulfur, and then I'm going to also get oxygen. Now oxygen is by itself and it's a diatomic, so I'm going to put a subscript 2 there. Okay, once you have that predicted correctly, then we can go ahead and balance the equation. So we can check, and we have two coppers, coppers, oxygens, and sulfurs. I have two coppers in my reactants. I have one oxygen and I have one sulfur. And on my product side, I have two coppers, two oxygens, and one sulfur. So my oxygens are not even. So I'm going to put a 2 in front of my copper 1 oxide. So now I have 4 coppers, but I have 2 oxygens. So now my oxygens are evenly balanced out, but my coppers are not because I have 4 on one side and 2 on the other. So I'm going to put a 2 in front of my copper 1 sulfide. So now I have 4 coppers, but that also affects my sulfurs. So now I have 2 sulfurs. So I will put a 2 coefficient in front of the sulfurs, and now I am all balanced.